Okay, guys, now we will talk about balancing reactions using the oxidation numbers. In order to approach balancing reactions using the oxidation number, it helps us if we follow some steps. And of course, the first step, since we are using oxidation number, will be to define the oxidation number of each element in the reaction, participating in the reaction, identify the number of the change on the oxidation numbers of the element, and then see and notice what is identify the number of electron transferred per atom, manipulate that into the number of electrons per reactant, find the lowest common multiple between the two, and then transplant those those numbers that we are using as to finding the lowest common multiple as a coefficient in the reaction. And then for the rest of the elements, we balance by inspection. So now let's take a look at this reaction that is here. And first we will identify the oxidation number for each of them. We know that oxygen is a -2, and a compound or an element should be equal to 0, unless it is an ion, which the total number of oxidation for the element has to be equal to the charge of the ion. So in this case, the hydrogen will be +1. And when we take a look at N2O4, then we can say that 2, that is the number of atom for nitrogen, which we will find the oxidation number, plus 4 times the -2, that is the oxidation number for oxygen, is equal to 0, since there is no charge there. Then 2x minus 8 is equal to 0. Adding 8 in both sides, we will have 2x is equal to +8. Divide by 2 both sides. Then the oxidation number of nitrogen will be +4. The oxidation number of bromide, since it is an ion, it's a -1. And the same logic we'll use at the finding the oxidation number of nitrogen, but now instead of equaling it to 0, as we did in this case here, we will equal it to -1, since there is an ion form of it. So x minus 4 is equal to -1. Add 4 in both sides, then x is equal to +3. So this will be +3. The same logic as bromide 3 oxide. The oxygen is -2. That let's find what is the oxidation number for bromine. So bromine atom. So 1 times x plus 3 times the -2 will be equals to -1, because this is the charge of the ion. And then x minus 6 equal to -1. Add 6 in both sides. Then x is equal to +5. So the oxidation number of bromine is +5. And for hydrogen is +1, because this is the ion. Okay, so now the second step will be to identify which one is changing the oxidation number. So the one that are changing the oxidation number are nitrogen, that is going from +4 to +3. Okay, and then the next one that is changing the oxidation number is bromine that is going from a -1 to +5. Okay, so now what does that mean is that nitrogen is gaining 1 electron. Okay, is gaining 1 + 1 electron, and bromine is losing 6 electrons. Okay, so let's write this information here. So it's saying that per atom, this is what it is, the third step. So find the electron transfer per atom. So we have nitrogen is 1 electron per atom is gaining, so per atom, so N. And for bromine, as we are losing 6 electrons. Okay, so the fourth step here, as we mentioned, is find the electron transfer per reactant. So we will go here and then we will see how many atoms of nitrogen do we have and how many atoms of bromine do we have. Okay, so then we see that the next steps. So this is per atom. And this one here will be per reactant. So for nitrogen being at N2O4, we will have 2 electrons per that reactant. And since bromine is the same, then we'll have 6 electrons per bromine. Okay, so now the fifth step is to find the lowest common multiple. Between 2 and 6, and between 2 and 6 is 6. Lowest common multiple is 6. So therefore, we have to find the coefficient that we are multiplying 2 by to give us 6. And we will use those coefficients to balance. So what is the number that you have to multiply 2 by to give you 6 is 3. And what is the number that you have to multiply 6 by to give you 6 is 1. So now it's taking those coefficients and placing them into the reaction. I will bring the reaction here again so that we don't make them. So this is the reaction without the oxidation number. So we'll take that 3 coefficient that we multiplied and N2O4 and place it here. And now since we are doing so, then nitrogen is a 6 here. And for bromine is 1, and the same thing is happening here. So now the rest of them will be balancing by inspection, which is something that you have done in every single class. And I will just suggest you to stop the video here and try to balance it on your own, and I will balance it for you or show it balanced for you. So by adding 3, you are making 12 oxygen plus 1 oxygen that is here will be 13 oxygen in total, and here on the reactant you will have 12 oxygen plus 3 oxygens here. So if you put a 3 in front of water, then you will have 15 and 15, oxygen is balanced. And then you take a look at the hydrogen. So nitrogen, oxygen, and bromine are balanced. And then you have 6 hydrogen on the reactant. So you add a 6 here, and then this is balanced. So this is how we use the oxidation number to balance reaction. I will post here another example, and then I will quickly go through the steps and explain it to you again, and we'll see more examples like this in class after that example that I will do now. This is the reaction. Let's first find the oxidation number of each of them. So oxygen is -2, so AS we don't know, 1 times X, something that we don't know, plus 3 times -2 equals to -3. So X minus 6 is equal to -3. Add 6 in both sides. Then X is equal to +3. So +3 for AS. And then the same thing here. Oxygen is a -2. 1 times X, which we don't know for iodine, plus 3 times -2 equals to -1, because the oxidation number of an ion will be the same as the charge of the ion. So X minus 6 is equal to -1 plus 6 in both sides. So X is equal to +5, so +5. Let's follow the same logic for ASO4, so -2. So 1 times X plus 4 times -2 is equal to -3. Then X minus 8 is equal to -3, adding 8 in both sides. So X will be equals to 5, so +5, and for the ion is the charge of the ion, -1. Okay, so this is finding the oxidation number. Now let's identify which one is changing the oxidation number. So the numbers that are changing are a +3 to +5. And the other one is iodine from +5 to -1. So when we see this, we realize that what is happening with AS is losing 2 electrons. And what is happening with iodine is gaining 6 electrons. It's +6. So now when we identify the number of electrons per element, then we will have AS is -2 electron per atom, and iodine is +6 electron per atom. So this was per atom. This is the third step, I think, per atom. And then when we are finding the electron exchange per reactant, then we will take a look. AS is only 1, so will be for AS will be -2 electron per ASO3, and per iodine will be again 1, because we have 1 iodine here. So will be positive 6 electron O3 minus. Okay, so now we find the lowest common multiple between 2 and 6, and it is 6. So that means that what we will do to 2 is we'll multiply it by 3, and what we'll do to 6 will multiply it by 1. Okay, so now we'll go to the elements or the reaction here, and then we'll add 3 in front of AS, okay, and the 1 in front of IO3, and now we will balance the rest. So by inspection, 3 AS, 3 AS here, 6 plus 3 is 9, 6 plus 3, no, 3 plus 3 times 3 is 9, plus 3 is 12, and 12 here, and iodine is balanced as well. So everything is balanced, and this is how we balance using the oxidation number. And this concludes the lessons for the day. We will do more examples in class. See you there.